Assalamu alaikum. Good morning, everyone. How are you all? Hope you are all okay and fine. Today's lesson is 11.5 Angle Relationships in Circles. Our main objectives today is to find the measures of angles formed by lines that intersect circles and to use angle measures to solve problems. Okay, the first theorem in this lesson here, basically this lesson is talking about the lines that intersect the circles. As we knew before, we have many lines or many types of lines in the circle. The first one, as we took before, is the tangent, BC. And also we have another line or another type of lines, which is the secant, BA. So if here in this theorem, if a tangent and a secant intersect on a circle. Look, the intersection of the tangent and the secant is on the point of tangency, which is B here. If these two lines intersect in the point of tangency, then we have a relation between this angle, angle ABC, and the arc AB. Measure of angle ABC is equal to half of measure of arc AB. It means if the measure of the arc AB, for example, is 60, then the measure of this angle is 30. If measure of this arc is 100, then measure of the angle is 50. If this angle's measure here is, let's say, 20 degrees, then the measure of the arc is 40. I think the idea is clear. So the measure of the angle is half of measure of the arc, or measure of the arc is double of measure of this angle. Example on this theorem, find each measure, find measure angle EFH. EFH. Look, EFH is an angle which is formed by the tangent EF and the secant FH. Look at the name of the angle, EF and FH. EF and FH. EF is a tangent and FH is a secant. As we said in the theorem, if a tangent intersects with a secant on the circle, on the point of tangency, then measure of the angle is equal half of the arc. So, measure of angle EFH, half of measure of the arc FH, which means that it is half of the 130. This is 130. So divide it by 2 to get measure of this angle, which is equal to 65 degrees. Okay. The second one here, find measure of arc GF. GF. Arc GF. How to find measure of arc GF? Now look, we have here a given information about this angle, but this angle is behind the secant. We want to know the angle which is here, which is between the tangent here and the secant. What is the measure of this angle between them? Look, we knew from before that we have to subtract from 180 this 122, and this angle that we want to know here is a linear pair. From the linear pair theorem that we took in the first semester, they must form 180 degrees, so we subtract 180 minus 122 to get measure of this acute angle, equal to 58. This equal to measure of arc GF. Now, as we said, arc of GF is double of this, the double of this angle. The double of this angle is 58. So we multiply 58 by 2 to get 116, which is the measure of the arc GF. This is equal to double of this angle. 2 times this angle, 2 times 58. Okay, and check it out one. Find each measure again. Measure of angle STU. STU. What is the relation, or what is the intersection here? It is in between what and what? It is in between secant and the tangent. Okay, tangent and secant intersect on a circle on the point of tangency. Then the relation is the measure of this angle is equal half of this arc, as we knew from the theorem. So measure of angle STU is equal to half of the arc ST. Okay, which is half of 166 equal to 83 degrees. Okay, measure of arc SR. SR. SR again, it is in between the secant SR and the tangent QR. Now QR, tangent QR, secant SR intersect on R, the point of tangency. So as we knew in the theorem, this angle is half of this arc. Measure of this angle is equal to half of measure of this arc, or measure of this arc is double of this angle. So simply we write the theorem and we substitute, then multiply by 2 to get 142 degrees for measure of arc SR. Okay, the second theorem today in this lesson is if the two secants intersect, or two chords intersect inside the circle. Look, two secants, these are here chords. This is a chord and this is a chord. But if we draw a line, if AD is a line and CB is a line, so they will be a secant. No difference here actually, because the main important, or the most important thing here, that they intersect where? They here intersect inside the circle. Now they intersect inside the circle in point E here. There in the previous theorem, if you remember, secant and tangent intersect on the circle. But here inside the circle, they intersect inside the circle. And here we have two chords. There we had secant and tangent, or chord and tangent. Okay, if the two secants or the two chords intersect inside the circle, so how much is this measure? Measure of angle 1, the angle of intersection, measure of angle 1 is equal to half measure of the behind arc plus measure of the front arc. Again, measure of angle 1 is equal to half the addition of this arc plus this arc. A rough example, if measure of this arc, let's say, is 60 degrees and measure of this arc is 120 degrees. Okay, so how much is this measure? To find the angle measure here, we will add this arc and this arc, then divide the answer over 2. 60 plus 120 is 180, or 60, we said plus 120. 60 plus 120 is 180 divided by 2, so it will be 90. This is a rough example, of course, but this is the idea. To find the angle, the angle measure, which is inside the circle. Inside the circle, we add the behind arc and the front arc, then divide the answer by 2. Let's see an example of this. Find each measure. Measure of angle AEB. AEB. This angle is inside the circle. Be careful, it is not a central angle. It is a normal angle inside the circle. It is the intersection of two secants here. These are two lines intersect inside the circle on E. So this measure of this angle AEB, as we said, we have to do what? We have the measure of the front arc and the behind arc. So to find this angle, we will add the front arc plus the behind arc, then divide the answer by 2. This is the theorem. So we will write the theorem. It is half multiplied by measure of arc AB plus measure of arc DC. Substitute the measures, then find half of 252 to get 126 for angle AEB. Another one, check it out, 2. Now find each angle measure of angle ABD. ABD, this angle here. ABD, we want to find measure of this angle. Again, we have the behind arc and the front arc. We want to find this angle. So the plan is in your mind must be like this. We will add the front arc and the behind arc, then divide the answer by 2. Write the theorem's formula. Measure of angle ABD is equal to measure of half of measure of arc EC plus measure of arc EAD. Substitute the measures. Then 37 plus 65 equal to 102. Divide the answer by 2 to get 51 for this angle, for ABD. For this angle here, it is 51 degrees because it is half of the sum of the two arcs. Okay, now and check it out 2, example 2. Find also measure of arc RNM. This angle. Now we have here a small problem, which is what? That we don't know this angle. We want this angle here. We don't know the measure of the front arc nor the behind arc. What do we have to do in order to know the measure of this angle? We know here the given information is about those two arcs, MQ and RP. So here simply we can find measure of this angle as an idea, this angle here. Then we can subtract it from 180 because those are a linear pair. Okay, let's start the solution. Half of measure, so measure of angle M and Q equal to half of the two measures MR and QP, but we don't know any one of them. So here measure of arc M and Q equal to half of 91. Look, we found here M and Q, this angle here. It is 191 plus 225 divided by 2 to get 158, this obtuse angle. How to know this acute angle? This acute angle and this obtuse angle form a linear pair. So we will subtract it from 180 to get 22 degrees for this small acute angle, which is equal to also this angle, 22 degrees. Thank you for listening. Hope that you understood everything. Bye-bye.